So we found the p-value is 0.33, but what does that mean? Well, just a reminder, statisticians say probability is low if it's less than 5%. If it's more than 5%, it's considered high. So let's take a look here at our p-value, our probability. Is 0.33, is that greater than 5% or less than 5%? Well, 5% is 0.05, so this is actually greater. So this is considered to be a high probability by statisticians. Okay, so 5% is the cutoff. Now, what does this probability of this quote-unquote high probability mean? Well, what it's really saying is if the population average, if mu was 346, remember, we don't actually know what it is. We're saying the sample average was 352, but if this was true, if the population average was the same as it was last year, then the probability of getting a sample average like we did would be 33%. Since statisticians consider this high, we say then that the difference we're seeing is likely due to random chance. And so we say the difference is not statistically significant. So from a statistician's perspective, they would say that 346 is the same as 352. Now you might be like, well, no, it's not. But remember, this is statistically. They are not far enough apart that we can say the difference is due to a change in the population average. All right, so we actually just did 6B. Let's do 6C. So similar setup. We are testing, well, 380. It seems like 380 is significantly higher than 346, doesn't it? So mu naught is 346. We don't know what the population average is this year, but we know the sample average is 380. We know that N is 20 and S is 60. So we're going to go to our calculator and we're going to run a hypothesis test called a t-test. So we're going to go stat over to test, choose number 2. Mu naught is 346, x bar is 380, sample average is 60, sample size, sorry I said that wrong, sample average is 380, sample standard deviation is 60, sample size is 20, and we're testing to see, has my population average, is it greater than 346, so greater than mu naught, and then we're going to hit calculate. When we do that, we find that the p-value is 0.01. Okay, now remember we're comparing this against 5%, so compared to 0.05, this is less than that. So the probability statisticians would say is low. So what does this mean? This means that if my population was equal to 346, the probability of getting x bar equals 380 is 1%, which is low. Okay? So if it's so low, then this means our conclusion is this is probably not true. Mu is probably not 346. In fact, we're going to conclude that mu is greater than 346. And so our conclusion is the difference is statistically significant. So, quick summary here. When we have sample data, like 380, and we want to see, is it actually higher than 346? Or is this just due to chance? I should be more careful with my words. 380 is higher than 346, right? We would all agree. 380 is higher than 346. What I'm really saying is the population average higher than 346. We know the sample averages, but is the population average? And so we run this test and we find a low p-value. If the population was equal to 346, it's unlikely that we would get the sample average. So our conclusion then is that our population average is greater than 346, and the difference between 380 and 346 is statistically significant. Hopefully that helps.